மேம் ஸ்டார்ட் பண்ணிக்கீங்களா மேம்?
Good morning to all. On behalf of the Department of Civil Engineering, Branson's Institute of Technology, we welcome you all for this webinar on Trenchless technology by Mr. Adityan, the project manager of Pharma Liner Industries, Singapore Private Limited. So a brief about Adityan to proceed. He is a proud alumni of our Bransons of the batch of 2012 to 2016. He is an experienced project engineer with a demonstrated high history of working in the construction and utilities industry, skilled in pipeline rehabilitation, asset management, leak testing, Trenchless technology, project management. He is also involved in project tenders to handover stage. Currently, he is a project manager at Pharma Liner Industries, Singapore, and he has worked on various projects. Currently, he is working on the repair and diversion of sewage systems in Singapore. Some other projects done by him are for embedded pipe of water turbine and AC systems, Indonesia, rehabilitation of old clear water tank inlet and outlet pipelines and treated water pumping station suction pipelines, Singapore, oily sewer CCTV inspection, Singapore, lining work underground seawater return pipeline 1200 mm to 253 meters, Singapore, JTZ lining work phase 1, 2, 3 and 4, Singapore, drain line CCTV inspection work, Singapore, refurbishment of tanks and pipes at Ulu Pandan Water Reclamation Plant, Singapore, UG pipe leak detection of L1 PWP lines, Dubai. He is also skilled in AutoCAD, Autodesk Fusion 360, Microsoft Office, and MS Project. He has the programming and digital skills of computer programming in HTML, CSS, PHP editing, website and mobile app, in-depth knowledge of website design and development, small to medium scale mobile app development, currently developing a mobile app for rehab contract, digital marketing, search engine optimization and link building strategies, inbound methodology, market sentiment analysis. And we at Johnson's are very much happy and proud to invite him for this webinar. Now the session will be handed over to Adityan. Adityan, you could continue.
Good morning to all, and I'm very glad to be part of this webinar, and thanks for the invitation from Johnson's Institute, especially from Agnes ma'am, to have me invited to conduct this webinar and to connect with the students. So we are going to discuss about Trenchless technology, which my company is part of, and there's an entire industry in this Trenchless technology, which is very much it is in developed countries. These technologies are being used in a vast scale. In India, it is slowly developing, and this is the short intro, and quickly we will go into the presentation so that we will know what we are talking actually. Let me put into the presentation mode. Okay, I hope you can see my screen. So, Pharma Liner Industries Singapore Limited. We usually deal with the underground pipelines, not only underground pipelines, embedded pipelines which cannot be accessed through excavation or open cut methods. So, this is what we are going to discuss today. So, what is Trenchless technology? Then, history of Trenchless technology. What are the techniques available in Trenchless technology? Then, in these techniques, we will be concentrating on CIPP lining part alone, because this is what we do day by day. So in CIPP, there are three various techniques which we handle. So one is inversion lining system, another one is pull-in-place system, and third one is UV lining system. We'll be seeing all these three different systems in detail. Then we'll be seeing about how we are designing the system, I mean the liner. Then what are the properties for these liners? Then how actually we execute a lining job. So after we see the introduction of each system, we will go and see how to execute an actual CIPP lining job with a case study. So Permaliner Industries is a leading manufacturer and supplier of trenchless pipeline rehabilitation equipment and materials, which is based in North America. So our headquarters is based in North America, and it was started in 1999. So from 1990 onwards, we were doing both manufacturing and equipment supplier, and we have around 1,400 installers around the world. The Singapore branch is dealing with mainly of installation, not of a supplier of equipment or materials. We are mainly focusing on installation of our products here. And Singapore branch is the head office for Asian region, which means we cover India, then Thailand, Malaysia, Indonesia, all Asian countries we are covering here. So project from these countries we will be dealing with. So this is a short introduction, and this Permaliner Singapore branch started operation from 2015 to cover this Southeast Asian markets. So this is our major services, what we are doing. So we do lining installation, then condition assessment. So if there is a pipe which needs to be rehabilitated or renewed, we went in there and we do the condition assessment. So after condition assessment, we also do for spray coating in addition to CIPP lining. I will show, or we will be talking about this later. Then pressure pipe rehabilitation also we are undertaking. Pressure pipe in the sense the industry or power plants pipelines, then drinking water pipelines. Then we are doing pipe cleaning or repair works also. Repair work in the sense open cut replacement. Wherever the trenchless technology or trenchless rehabilitation repair system is not possible, we will go into the conventional methods of repairing it. And apart from dealing with the pipelines, we also deal with manhole rehabilitation, underground tank rehabilitation. Then in industry cases, we also undertake leak detection jobs, which I will show you in case study, which we have done in Dubai. So first, this is our introduction, company introduction. Okay, that was a quick introduction of our company headquarters. So we will start the topic. So what is trenchless technology? Trenchless technology is a subsurface construction work which requires few trenches or no continuous trenches. So you don't have to, for example, if there is a pipeline of 80 meters underground, like 6 to 8 meters of depth, and there's a repair work you need to carry out at 20 meters or 30 meters. You don't have to go and dig the surface, above surface, and do the repair. Instead, you need to access the pipeline from both the end of the manholes, and with the help of the equipment, from the top surface itself, you can repair the underground pipelines. So basically, we are not going to disturb any of the above ground traffic or business or other activities. So this is what Trenchless technology is all about. Minimum disruption to the above ground services. So history of Trenchless technology, how this began. So in 1970, there was an engineer called Eric Wood. He was an innovator also, and he was working on his agricultural farm, and he had a mushroom bed. Mushroom bed is like in his garden, he had full of mushroom bed, and above this mushroom bed, there was a pipe going, and this pipe was leaking. So he wants to fix this pipe without disturbing this mushroom bed below the pipeline, and he cannot walk into the mushroom bed also. So what he came up with is he took epoxy resin and he took a plastic sheet, plastic tube. Then he mixed this resin and saturated the resin with the plastic tube. He pulled one end of the plastic sheet inside the pipe. After pulling it in the pipe all the way to the other side, he inflated the tube, which is mixed with the resin. After inflation, it takes the form of the pipe. Then the resin, naturally, epoxy resin, if you leave it in ambient temperature, it cues and becomes a hard-like surface. So naturally, he did this by himself. Then after this, he found that so we can repair the pipe without disturbing the surrounding environments, and the repair can be done in a faster manner also. It took him 2 hours only to repair this instead of replacing the whole pipeline. So he went and patented it and formed into a company called Institute Form. Till today, Institute Form is the major market leader in Trenchless technology, and they focus on only CIPP lining. So this is how all it began. And now the patents all expired, so there are many companies in this market. So this is the start of everything. And apart from this, micro tunneling, then tunneling, then pipe jacking, all these are Trenchless construction methods, which also began simultaneously in later years. So until now, all these technologies remain dormant, which means only a few countries were using it. But due to the global scale of expansion and advanced cities, there is immense need for these technologies to go for that. So we will see why this technology is going to be a future demand. So this is the entire Trenchless techniques available in current market. So there is the inspection. So in inspection, there is two types: location and condition assessment. The red color marked boxes are the one we are concentrating in permaliner. So if you see in location, there is a ground penetrating radar, sonar, then smoke and dye, soil assessment, etc. Then in condition assessment, we have CCTV inspection, leak detection, inflow and infiltration, sonar, laser, electromagnetic methods, etc. Okay, then we go into new installation. This new installation are, if you want to put a pipe from point A to point B, say about 20 kilometers, and this 20 kilometers of pipeline is in the city side, and above you have traffic, shop, then road junction, everything is there. So if you think about it, if you want to do this pipeline in conventional methods, you need to block the roads, you need to block the shop, house owners, everything, and you need to put a trench, then you need to lay the pipeline. But if you go through the trenchless techniques, right, you are going to use either pipe jacking or micro tunneling, auger pouring, all these methods, the new installation one. It will help you to put up a new pipeline without disturbing the above ground surface. So you are going to put the entry shaft and the exit shaft. Through the entry shaft, you are going to put in the machine. For example, for pipe jacking, you are going to put the thruster over there. Then you are going to put the pipe jacking machine, which will core the earth below the ground, and you will take the soil from the underground and you will install the new pipeline. So above surface remains the same, and there you will get a new pipeline below. Then comes the rehabilitation part, which our company focuses on. In rehabilitation, we have renovation, non-structural and structural. Non-structural is for structures such as sewer systems or tanks, which don't need any structural capabilities. So cement mortar lining, epoxy lining, polyurethane lining falls under non-structural. In structural lining, we will see CIPP lining, spiral wound, close fit lining. So now I think you don't know what we are talking. I mean, these are the techniques. You have this in mind, then when we are seeing the videos in later slides, you will know what is the CIPP lining, structural or non-structural, and what this methods are about. And if you go to replacement, so you have one underground pipe, and this pipe you deem that it cannot be used. So instead of putting a trench, removing it, you can expand the same pipe. For example, you can use the method pipe bursting. You will be pulling in a pipe bursting machine inside it, and this pipe buster, it will crack open the existing pipe, and it will pull inside a new pipe. So there are a few methods in this, and there is a repair method also, joint grouting, localized sealing. All these methods, if you don't want to replace the entire pipe or renew the entire pipe, but you want to address the concern in specific location, so you will be using these methods. Later, I will show you a video on this also. So moving on to CIPP inversion lining system. So first I will show you the video, then we will go into step by step of how this method is installed. This CIPP inversion comes under renovation technique and trenchless techniques. So this method, what we will be doing is for sewer pipes or whatever the underground pipe is, if the pipe condition is not good and we wanted to replace it, so instead of putting the trench, we are going to do it in a CIPP immersion method system. So we will see a video of how it is done.
வீட்டுக்கு போயிருப்பாருன்னு நினைக்கிறேன். வீட்டுல இருந்து வந்துட்டாங்க. இன்னைக்கு தான் போறாரு.
This is how the liner goes inside the pipe. So when we give air, the liner inflates like a balloon and it starts inflating like this. So it reaches the other end of the pipe. So once we leave it to cure, it becomes so strong, and now once this becomes strong, the hose pipe doesn't need to be strong, or it can crack or whatever happens. We don't need to care. So we basically form the pipe inside the pipe. So once forming, we will send in this robotic cutter to reinstate the lateral connections. So this is how we will be doing. Any lateral connections joining the main pipe will be reinstated back to its original position. So let me go through again. So first we do a CCTV inspection. So we will assess the condition of the pipe. Then after assessing the condition, we do the cleaning with hydrojetting, or we use any chain cutters. Later I will show. After this, this is the liner and the calibration tube. So calibration tube is to inflate the liner to the hose pipe. So once we measure the liner size and calibration tube, we will pull it inside like this. You can see how they are pulling it. So once everything is pulled in and it is in place, now we start mixing the epoxy. This epoxy is the main component here, because there are in epoxy there is two parts always, part A and part B. Part A is the resin and part B is the hardener. So it is usually in our system we use 2.6 kg per meter, 2 kgs of part A and 0.6 kg of hardener. And depending on the site condition, the hardener's quantity may increase or decrease. So once this resin is mixed, once you pour in part A and B together and you start mixing, your time starts ticking, because in this industry, in CIPP industry, it is like a time bomb. So the time bomb means it doesn't explode, but if you mess up with this, your entire job will be failed. Because once part A and part B is mixed, the resin starts getting harder. Like how you do the concrete work, you do the once you mix the cement with aggregates, everything, and the concrete gets hardened, right? Similar way, the epoxy also will get it harder. That's how the liner is getting the strength from. So, so once the resin is mixed, you need to start counting the time. Usually, the resin data sheet will show you what is the working time of the resin. Either it is 30 minutes or 45 minutes. So it depends on the resin type. There are slow cure resins which cure slowly, usually take 45 minutes to 50 minutes. And there are fast cure resins. It will take only 15 to 20 minutes. Fast cure resins are used for shorter length of pipes, and slow cure is used for longer lengths. So once they mix the resin, they pour the resin into the liner. So after pouring into the liner, we will be wetting it out. This is the wet out process, and the machine is used for wetting out the liner. Wetting out is simply removing the excess resin from the liner. We will pour the resin into the liner, then we will remove the excess liner from the excess resin from the liner. After it is done, we will insert the liner into our immersion gun. This is called immersion gun, the machine. So at the tip of the immersion gun, you just like how you put the socks, you will clamp the end of the liner in the machine's outlet point. So we are clamping it here. After you clamp it, then the end piece is fixed with the machine. Now you have to give air to the immersion gun. Once we give air to the immersion gun, the liner starts to invert. So this is how the process is done, and this is how the name is given to this. We are inverting the liner. So when air is given, the liner inflates itself like this, just like a balloon. How you inflate a balloon? That's the process going on here. Once the air comes in, it thrusts the liner outside, like inflating the balloon. And now you can see how it is flowing, how it is inflating inside the pipe. So no matter the pipe size, whether 100 mm or 600 mm, 1200 mm, if you go with the inversion process, this is how the liner goes inside. Once it reaches the other end, we will leave it for curing for 2 hours. Then after that, if you see the surface of the liner, it will be hardened. So this is the basic thing. And based on the video, right, you have seen materials for the CIPP lining. One is the liner, calibration tube, then inversion gun. Then we are using steam cure for this method. So if you see in cure method, there are a few options available. And resin type, if you see, we use epoxy for this. Okay, these options, it is available for all jobs. But depending on the site condition and the pipe condition, we will be selecting which liner to go with and which installation method, whether immersion method or winch in place or water immersion method. Water immersion is nothing like you use air to inflate the liner. Instead of air, we will be using water to inflate the liner. We go for water immersion usually for bigger diameter pipes. And there is a curing method, ambient cure. Ambient cure is nothing but okay, I'm getting the audio is low. Just a minute. Just okay. I think you can hear me now. Okay. So if you see curing method, there is ambient cure, then hot water cure, then steam cure, then hot water showering method, ultraviolet method. So ambient cure is nothing but curing the liner in the normal temperature, in room temperature. Hot water cure is you send in hot water inside the liner after it inflates. Steam cure is you send in hot air inside the liner after it is inflated. So resin type, polyester resin. This polyester resin is easy to work with, and usually for larger diameter pipes, we use polyester resin because of its workability time. Once the resin is mixed, we will have a few hours to install the liner. So this polyester resin, even if the job gets cancelled, you don't have to worry. You just put the liner into the ice box. That's all. It can withstand for another 24 hours. So usually for large diameter pipes, the wet out liner, wet out you saw right, resin mixing and wetting out the liner with resin. This process is done 1 day prior to the lining, actual lining job. So that is the advantage of polyester resin. And epoxy resin, though it is like time warm, but we have some advantages of epoxy resin also. For example, in Singapore, if you go and do the lining work inside the house, which we call private premises, you have limited time. The owner gives you 2 hours or 3 hours time to complete all your work, and you need to move out from their house. So within these 2 hours, polyester resin will take a lot of time to cure. But in epoxy resin, if you use epoxy resin, it will cure from 2 hours. So it will take minimum 2 hours to cure. So that are the advantages and disadvantages here. And based on the, as I mentioned, based on the site conditions, we will be choosing the methods to go with. So this is the method statement overview. In Singapore, we have method statement, risk assessments, safe work procedures for each type of the work. And this is just an overview of the method statement. As you saw in the video, we will do CCU inspection first. Then once the CCU inspection is done, we will clean the pipe if required. If not, we will install the liner. After liner installation, we will inflate the liner just like the balloon how you saw in the video. Once the liner is inflated, we will cure the liner. So you know the curing method, we use air or steam or water or UV light. So after the liner is cured, if any lateral connection is joining the pipe, we will reinstate the lateral connection back to its original position. Then we will do a post condition survey also to check whether the liner is inserted properly or not. Then in few cases we do hydrostatic testing. Then after that the hose pipe is received to service. So it is a 8-step process. So these are the materials and equipments which we use for lining. This is the liner, actual liner. This liner, right, if you see from picture, it will look like something different material, or you will not have understanding. But to be very generic in terms, right, this liner material is nothing but uh, like like your jeans pant, we can say like that. Your jeans pant material, right, it looks like that, but the thickness of the material is harder. So it is a felt liner, felt in the sense it is used for dress manufacturing also. So basically, you see your pant or you see your clothes, that is how the liner looks like, but the thickness is very harder. And we have many manufacturers in India also who does this manufacturing of the liners. But since our country is not into this lining yet, they export these liners outside the world. So this is the liner, and this is the inversion gun. So this inversion gun you saw, right, in the video. We will feed the liner inside this inversion gun, and here you can see two nozzles. In one of them, we will connect to the compressor to supply air to the gun. In another one, we will connect to the steamer to supply hot air. So during the liner installation, we will control this valve here to thrust the liner inside the pipe. So in the video, you saw how the liner goes inside the pipe. So it uses the air to proceed forward. So once the liner is inflated and reaches the other end, we will close this compressor valve, and we will open this steamer valve. So once we open the steamer valve, hot air is passed into the liner, and it rapids the curing process. And you can see Top Gun liner system for bigger diameter pipes. This inversion gun is for smaller diameter pipes up to 250 mm, and liner gun with the Top Gun series you can go up to 350 mm, 400 mm. So this is the Top Gun series here. And apart from that, these are the cameras which we have currently in our inventory. So on the left side, you can see a crawler. This one is a magnetic crawler. This magnetic crawler we use for special type of jobs. For example, if you want to investigate tunnel lining, after you go inside the tunnel, top surface, everything, if you want to inspect it, we use this magnetic crawler. We do a special arrangement with the steel case, and we make a track-like structure in the tunnel surface. Then this crawler travels in the track structure, and it inspects the tunnel surface closely. And on the right side, you can see a normal inspection crawler camera. This camera we use for CCTV inspection for pipe diameters from 150 mm to 600 mm, and you can see it is having a lift also. So this is a panel tilt camera. These wheels can be changed depending on the pipe size. So currently they have finished 600 diameter inspection. So you can see the wheels are bigger. So, and this is another camera. This camera is explosion proof camera, which we can use in chemical industries, mainly oil and gas chemical industries. And you can see after the inspection how the wheels are covered with sludges inside the pipe. So this camera, though it looks smaller, but it is very powerful. The traction motor inside the crawler is quite powerful. So you can trust these cameras in all kinds of pipes, or whatever the difficulty is. And this is a robotic cutter which we use for our jobs. So you have seen in the video, after we install the liner, we need to reinstate the lateral connection. So to reinstate the lateral connection, we send in this cutter, and exactly we locate the lateral pipe connection, and we reinstate this. And for the lining job, we use a compressor and a generator. These are the equipments, basic equipments we use for every single job. So this is all this for pull in place, inversion lining system. So inversion is using this equipment, top gun series or inversion gun. There is another method called pull in place lining system, which you don't require inversion gun or top gun series. You can just you wet up the liner, you can pull the liner by yourself and inflate it. So that is the difference here, and I will quickly show you a video. They are mixing the resin here, part A and part B. So now the mixed resin is poured inside the liner. So after pouring the resin inside the liner, they are wetting out the, saturating the liner with the resin. So all the excess resin will be taken off from this one. You can see how they are doing. It's a roller. And another thing is these rollers you are seeing right here, this have specific calculations to account for. For example, if you are using a liner of thickness of 5 mm, then this roller should be of 5.5 mm, 0.5 mm higher. So this there's a calculation for based on different kinds of liners and resin we use. So these rollers, anyhow, we cannot use it. We need to exactly measure the rolling gap which we require for this liner, and we need to set the exact gap. Then we need to wet out the liner. So this is done to, it is one of the quality control method to not to have excess resin inside the liner. If you have excess resin inside the liner and you cure it like that, you will see lining failures. So we don't want that to happen. So excess resin must be removed in the first step itself. So the calibration tube is inflected inside the liner. Now they are pulling in the bladder. The yellow color which you see is the bladder, which will be pulled inside the liner. This bladder is nothing but if you remove this bladder inside, you will see a tire tube. You can imagine how a tire tube looks like, but it looks in longitudinal direction. That's all. So inside this yellow color bag, basically you will have a tube inside it, rubber tube. It looks like a normal car rubber tire tube. So the inflation is done to this tube inside. So we call this as a bladder system. So once the bladder system, you can see liner is wet out, and after liner is wet out, we are pulling the bladder inside the liner. So after the bladder is pulled in, we need to send this liner inside the pipe. But you cannot send the liner without folding it, because if the pipe diameter is 600 mm and your liner is also 600 mm, you will have difficulty to push it in. So to avoid that friction and excess force required to pull, we will fold the liner in 3 folds. You can see they will be doing 3 folds. So once 3 fold is done, and we will use a masking tape to hold the, this is a masking tape. They secure this fold like this. So in like 1 meter interval, they will secure this liner. After that, you can directly take the liner and pull it inside the pipe. So he is tying the rope to the bladder, and you can see they are pulling inside the liner. after the liner is pulled in, as I mentioned, this yellow color bladder, right? Inside it, you will have tire tube-like structure, and you're just passing the air inside the bladder. So once you pass the air inside the bladder, just like how our vehicle's tire tube gets inflated, the bladder also gets inflated. And as you know, in the previous step, after this bladder, there is liner inside also. So the liner will take the shape of the pipe. So this is how it will look after the installation. So once the liner is queued completely, you are going to release the air in the bladder. Once the air is released, you can remove the bladder, just pull the bladder outside, and here your liner will stick to the hose pipe, and it will take the shape of the hose pipe. So once it queues, it looks like a brand new pipe. And this, all these things are polyethylene sheets. It is a covering sheet. It is the first layer of the liner inside it. So this polyethylene sheet is given to protect the liner from sewer waters and harmful gases. It is the first line of defense for the liner. So this is how it looks like. So in pull-in-place method, you're not going to use any inversion gun or big equipments to install the liner. You're going to wet out the liner, pull it in place with manpower or just one winch. Then you will inflate the liner and it will let it cure. That's all. So this is the three-step method how it is done. So you already saw the video how. And now we move on to the next system. UV lining system. So far, I will just recap. We have seen what trenchless techniques are, how many trenchless techniques are there, and particularly we are going into detail about CIPP immersion system and pull-in-place system. So past two videos here, you have seen two methods, and this is the third method in the line. And here all the method of pulling in the liner, everything is same. But the name as it suggests UV lining, what the difference is, once the liner is pulled in place, you're not going to use air or steam to cure the liner. You will be using UV light to cure the liner. And this UV light, right, the liner is already light sensitive. I mean, it is a glass fiber reinforced liner, and the resin is sensitive to UV light. So you put this liner under sun, it will cure by itself because of the UV light presence of the sunlight. And to store this liner, you need to keep it in dark boxes, and the temperature of the liner must be always within 22 to 25 degrees Celsius. So once you take out this liner and you install it to the pipe, until you pass the UV light, it will not cure. So many of the UV lining jobs are done for oil and chemical industries, and it is quite expensive method also compared to the other methods. And cost-wise, it is still cheaper when you compare with open cut excavation methods to replace the pipe. So, and the life of this is 50 years by design, and we have seen many pipes last for 70 to 80 years from our records. So we will see how the UV lining is installed. So first CCTV inspection is done, and they will send in a cable to establish to the other manhole. Now once the cable is established, they will pull in the gliding foil. So this gliding foil, the purpose of this gliding foil is, in the hose pipe, the pipe condition may be bad and there may be sharp edges. So once you inflate the liner, it is, as I mentioned, it is just like a balloon. If you inflate the balloon and poke it with the needle, it will blast, right? So we don't want that to happen with our liner. So we pull in a gliding sheet. This gliding sheet is, gliding foil is like a plastic sheet. So it will first it will reduce the friction and it will avoid the liner getting damaged when we are pulling it. So it will protect the liner when we are notice the cable how we are using. So once the cable is established, we will use the same cable to pull in the UV light cable also. So now the cable is connected and the liner is pulled in. You can see the liner is pulled in. After the liner is pulled in, inside this liner we will have one small cable. This cable is called pull tape, and this cable is mainly used to establish the rope for UV liner. I mean UV light to enter in. And the top you can see the cap, or we call it as a packer. So what we will be doing is we will connect the packer to one end of the liner and the other end also. You can see two hoses running, and one hose is for compressor or air blower to inflate the liner, and the other is for UV light. So the cable is there, we will be pulling it. So once this high strength cable reaches the other side, we will connect the camera, I mean UV light to the cable. So this UV light once connected, we will close the other end of the liner also. That's all. Once UV light is inside, we will pull to the start of the manhole. Now it is at the start. Once it reaches the start position, now the operator above the ground, he will on the UV light sources. So once the light is on, the chemicals inside the liner starts to react to the UV light, and it starts curing and getting harder. And there is a timing for each diameter pipes in what speed you need to pull this UV light. So slowly they will be pulling this light. All this pulling, everything is done by the machines, so it is automatic process. We will input the diameter, then full speed, everything, and the light intensity. It will be set in the system, and the system automatically pulls this UV light from one end of the other end. So the main advantages of UV lining is once you install the liner, pull the liner, and you start the UV light system, you don't need to look at it. The system does its job, and you will get the results. So once the curing is completed, you will not remove the UV lights until it cools down. If you see or if you expose to the UV light, you will have health issues. So once the light is cooled, and we will get alert in the system that we can remove the UV lights from the liner. Then once the system alerts us, we will remove it. Now this sheet you see, right? This sheet is a plastic sheet. It is for protection against the overexposure of UV light. So this sheet is one step of quality control. So once the liner insulation is done, from the inside this sheet will be peeled off and removed from the pipe. Now this is the robotic cutter entering in, and it will open the lateral connections inside the pipe. So this is how the UV lining system is done, and this is the exact machine which you are seeing. In the left side, you can see the UV machine. So this is the machine which controls the UV lining job, and behind it you can see a generator to support this machine. This is the entire vehicle we use for UV lining job. So you take this one lorry and you go to site, and you will have 50% of the equipments, and another lorry we will bring in liner. So you need three lorries at the site. One is UV equipment lorry, the other is liner lorry, the other is jetting truck. So later I will show you the picture of how a flushing tanker or jetting tanker looks like. So with these three lorries, you can finish almost jobs under 600 mm to 800 mm diameter. So this is the complete setup how we have in Singapore also. This is one of our lorry which we use here for UV lining. And the operator, there's a space behind the operator to sit and work with this equipment. This is the UV light, how it looks like. This is for the smaller diameter pipes up to 300 mm. You can see the wheels here, and you can see the lights over here. In the middle of the system, there is light. And this UV light bulb is changeable, so if it gets repaired or spoiled, we can change the bulbs easily. And the cost of the bulb is in average range, it costs about 1,000 euros or something. So it is not a big deal. And when you get a new equipment, you will have extra bulbs also. So this you can see an image. We have done a demo for our client in Singapore last month. So in the image you saw the packer, right? This is the packer, how it looks like. And you can see the gray color hose here and black color cable here. The black color cable is for the UV light pulling, and the gray color hose is for inflecting the liner. And you can see the liner is already pulled into the pipe, and the packer is being tightened up. So now, after the packer is tightened up, the liner is inflated here. So after the inflation in this step, already the light is inside the liner, and you can see in the left side the color difference of the liner here. The light is on at the left side end, and it is being pulled to the other end. And this machine is having a computer attached here. This is how the operator sits, and he controls the equipment. So basically, when the UV light is inside the liner, before even the UV light is going to inside the liner, we will input all the data of the liner and the hose pipe, diameter, length, then pipe material, liner resin type, the number of bulbs used, then manhole to manhole exact distance, and what are the other conditions such as any infiltration of water is there. For example, if any infiltration is there, then the light intensity should be higher. If water touches the curing liner, it will cool down the liner and it will reduce the curing time. So in order to avoid that, we need to increase the intensity of the light. So once all these data are set, you just need to on, you are seeing a white button here. Every data, once it is set here, and you need to just click this button. After that, you don't need to worry. You can just sit and watch how the liner is being cured. There's a camera inside the UV train, and it gives you a light feed of the pipe. So after lining is done, this is how it looks like. And in this case, we have not removed the polyethylene sheet yet. So you can see after curing how it looks like. It looks in green color. So okay. So far we have seen three methods in detail: CIPP lining system by immersion method, then pull-in place method, then UV lining system. So these are all overall methods how we have been doing all this way. So So once you know all this, it's just like you will have liner, you will have resin, and you're going to mix the resin, and you're going to pour this resin in the liner. You're going to pull inside the pipe, then you are going to inflate it like a balloon. After that, you're going to wait and cure the liner. After the liner is cured, your job is completed. That's it. So this is the general overview and how actual job is done and what are the technical considerations. So it is not like it's just a sewer system, so we can do anyhow. It doesn't happen like that. And since we are dealing with industry pipelines, each pipeline costs money. For example, we have done a job in Shell, Singapore. This pipeline is 1,200 diameter, and each day when this pipe is being shut down, the Shell company is losing around 50 million in Singapore dollars because this pipeline is a seawater return pipe. Their entire chemical plant depends on this pipeline to draw water from the sea and to give for cooling systems. So if this pipeline is down for too long period, and they'll be incurring huge loss in their operations. So in this type of situation, the
ஆல்ரெடி கொடுத்துருக்கேன். இப்போ கேட்டுட்டு உங்களுக்கு நான் பேசுறது கேட்கும். சார் ஒரு நிமிஷம் சார். உங்களுக்கு மாடல் இருக்கு. ரெஃப்ரெஷ் பண்ணுங்க. அண்ணா 3 ஸ்டார் இல்லை மறுபடியும் லாகின் பண்ணுங்க. Hello.
You are now muted. You are currently the only person in this conference.
இல்லை அது எதுவும் பண்ணணும். ஆதித்யா சார் கொடுத்துருந்தேங்க சார். வெளியே வந்துட்டாங்க. வெளியே வந்துட்டாங்க. இல்லையே அவர் கொடுக்கவே இல்லையே. கௌதம் இருக்கு. கௌதம் ஆல்ரெடி இருக்கு. ரெஃப்ரெஷ் பண்ணுறப்ப கேட்காது. நான் ரிமெம்பர் தான் கொடுத்துருக்கேன். சரி ஓகே சார். சார் இப்போ வர சொல்லுங்கள் சார். இப்போ வந்துட்டேன். ஆன்லைனில் இருக்குது. ஓகே ஆன்லைனில் இருக்குது. இப்போ அவர் திருப்பி கனெக்ட் பண்ணி எல்லாத்தையும் ஜாயின் பண்ணிக்கோங்க சார். எல்லாருமே வெளியே வந்துட்டீங்களாட்டிருக்கு. ஓகே சார் நான் வந்துடுறேன். வாங்க. வரேன் சார். அக்செப்ட் பண்ணி தான் இருக்குது. ரிமூவே பண்ணுறேன். இப்போ கொடுங்க திருப்பி. இது ரெஃப்ரெஷ் பண்ணிட்டு மறுபடியும் போடுங்க சார். எது சார்? இது ரெஃப்ரெஷ் பண்ணிட்டு அக்கவுண்டிங் டு கனெக்ட் ஆகும். எது சார்? இல்லையா ஸ்லைட் கரெக்டாக தான் இருக்கு. இது ரெஃப்ரெஷ் பண்ணிட்டு ரீலாகின் பண்ணுங்க. லாகின் எங்கேன்னு போட்டுருங்க. 1
Okay, I think there is a network issue, and I hope we are back online.
Okay, sir. Stream start பண்ணிடலாம்ல stream.
ஒரு 2 நிமிஷம் இருங்க.
Stream start பண்ணி விடலாமா?
ஒரே நிமிஷம் இருங்க. நான்
ஸ்டார்ட் பண்ணிடலாமா?
எஸ் சார். சார் இருங்க வந்துருச்சு. வார்னிங் டேட்டா வந்துருச்சா? டேட்டா குட் கனெக்ஷன். இங்க இன்னும் வராது.
Okay.
சார் OBS மட்டும் ஸ்டாப் பண்ணிட்டு ஸ்டார்ட் பண்ணுங்க.
OBS ஸ்டாப்ல இருக்கா?
ஸ்டார்ட் பண்ணுங்க. நோ டேட்டால இருக்கு.
So we have spoke about the lining processes. So how we are determining the liner thickness, everything, it falls under ASTM F1216 standards. So these are all engineering calculations which we must do before undertaking any installation jobs. So basically it governs by ASTM standards only, and I will show you this. So left side you can see the pipe diameter sizes, and on the right side you can see the minimum liner thickness which we need to use for. So for example, if the pipe size is not exceeding 152 mm, then the liner thickness must be at least 4 mm thick. So I will show you how this calculation is done quickly. So these are the properties of the cured in place lining system. So whichever the lining method we use, it is no problem, but the liner must, after installation, these are the properties it needs to achieve. So in Singapore, before we even install it for PUB is the Singapore's Public Utilities Board. Sewer lines and drinking water pipelines, drain lines, all this in entire Singapore is controlled by them. It is a government authority. And for PUB jobs, everything we need to have, we need to show them the proof that our liner matches this criteria before we even install the liner. So in private industries also, if you go in, they will ask for these properties. So what's our technical properties of the lining system? So this is it. And quickly we go into the planning step now. So you know how the liner is. So we have spoke about the lining system and how it is being installed. Now you can have some imaginations. Okay, this is the process, but how it is done actually on site. So I'm going to show you how it is going to be done on the site. So these are the 8 steps. SIP means Sewer Interpretation Plan or Sewer Information Plan. So usually I will show you just a sample SIP here. So if you see, first we get this SIP from the client. SIP shows the plan of the sewer system, where exactly it is, what is the diameter, what is the length, and access points. It is like Google Maps for sewers. In Singapore, the government is having a sewer system, SIP for entire Singapore. So you will know all around Singapore underground where the pipes are and where the manholes are located exactly. And I will show you an example for that. Once we locate the pipe, then we need to do precondition survey, then liner design, resin calculation, then job safety must be planned, then install the liner, reinstatement, post condition. So quickly we will go into the details. So this is the SIP as I mentioned. If you see in this, I have already marked the sewer pipes. This job we are undertaking now, and last week my team went for a pre-con survey. If you see here, the marked pipes are the ones we are going to rehabilitate it. And this one, all these lines falls nearby the road and on roadside. So if you notice, this pipe is 37 meters of 300 mm diameter, and this is 113 meters 300 mm again, and 118 meters. So the client is PUB, so they don't want to change the entire length by open cut method because of the road area. And behind there's a school here. You can see from the map, Japanese school entrance is here. So we can assume that this is the school area and it is the road area. So once we get this map, we study this map. So this red color one is the manhole ID and violet one is the sewer ID. And you will have for every manhole you will have two IDs, manhole ID, and for every line you will have one sewer ID. So here the manhole ID is 3039708 and the downstream ID is 3039711. So for pipe, you will have basically upstream and downstream. So it is like this. So since it is a sewer pipe, the flow is gravity. So upstream and downstream. And how we can determine the upstream downstream is by the flow direction over here. So this is the upstream 708 and 711 is the downstream. Usually the liner should be installed from the upstream direction where the pipe flow is actually happening. And you need to know the depth of the manhole also. So here you can see two numbers here, 126 and 112. And the difference of these two numbers gives you the manhole depth. So that's all. We are having pipe length we have and manhole IDs, sewer IDs we have, then pipe diameter we have. Now what we need to look is we need to see the actual site before we even mobilize our vehicles over there. Because you know we need to mobilize few vehicles like jetter truck, everything. We need to see the location beforehand. So this location is Pachangi North. So I'm showing this because in Singapore the sewer information plan is very accurate, and before even you go, you can see in the map exact manhole ID also. So we open the map here. We see Upper Changi Road North. Okay, and now we are in Upper Changi Road North. So now we need to locate this pipeline. Okay. You see backside there is a unit number 11, right? You can see the number 11. So you just put 11 Changi North and here you have. So now I will go into the street view. Now we are in the exact location. So now in the map you can see here there is one manhole ID here and this is the road junction and here is the unit 11. At the corner of it you are having one manhole ID here. So if you locate this, you can locate the other entire lines. So I'm going to locate this in the actual area here. So if you come a little bit here. You can see here, this is the manhole. I hope you can see it clearly. Just a minute, I'll zoom it. Okay, you see here, there is a manhole in the corner. Okay, this is the manhole here. And if you see the distance from this manhole to the upstream manhole, it is 37 meters. So from here, and if you go by this, this way, you should see the other manhole in 37 meters. Wait a minute, I will zoom out. So we located one manhole here, and from here 37 meters around here, 37 meters. So this is how we will, if you want to do a measurement, you can do a measurement from here, and you can keep a distance of approximately 33 to 35, and you can see the location how it looks like here. So opposite you have a building. Then just like previously, you need to drop a man here. Then you need to go this side and you need to survey this side. Let's locate the other manhole also. Here it is. So you found the other manhole here. So if you see from this side to opposite side, we are having the building here. as we saw in the plan view. So this is how we locate the manholes before even we go to the site. So once we locate the manhole, so one is here, and the other is somewhere around here, as per the plan here. So once we located the manhole, what is the next step? Pre-con survey, then liner design. Okay, I will go into liner design first. I will quickly show you the calculator we use for day-to-day job. So this is the liner design sheet, and Applied Fields is one of the liner supplier. And you see here pipe diameter. So now we see what is the pipe diameter is 300 mm. Okay, 300 mm. And the external diameter changes automatically. All these values are input already. You don't need to change this. And ovality factor, if the pipe is oval in shape, you can put the percentage here. If not, leave it. And height of the soil above top of the pipe. This is the depth of the pipe. So now you need to know the exact depth of the pipe. So you have two depth. One depth is here and one depth is here. You need to always take the downstream manhole depth because it is higher than the upstream. So the exact calculation is 126.441 minus 112.459. So it is around 13.98. So exact manhole depth is 13.98. We will put 14 meters, and height of water above topsoil. So you need to account for the water also. Usually in Singapore, if you go below 5 meters depth, you can see groundwater inflow. So 14 minus 5 is 9 meters. We will assume 9 meters. So once you input this detail and this detail over here, and if you come below, the factor of safety is 2, you will know the liner thickness 8.28. It is fully deteriorated pipe. There is two thickness, partially deteriorated and fully deteriorated. Partially deteriorated is the hose pipe is in half good condition, half bad condition. So you can go for partially deteriorated. If the pipe is in fully bad condition, you need to go for fully deteriorated. In Singapore, no more partial thickness calculation is approved. So they done away with this. So only fully deteriorated liner thickness we need to follow. So 8.28, the closest thickness around natural number is 8. So we need to have minimum thickness of 8 mm liner to install here for this line. So now we know the liner design also we calculated from the spreadsheet. It should be 8 mm thickness. So after we found out the thickness, we just need to order for the liner and wait it. Next part is you need to calculate the resin quantity. Okay, so liner design is one part and resin quantity determination is other part because you don't want to waste resin also. There's a calculation for resin. All this we have inputted the data previously and we use this for our job. If you see, we are using two-part epoxy resin, part A and part B, and their percentages, then mix ratio, then their consumption rate is included, and porous volume also accounted for. Now there is we need to enter basically three details: length, diameter, and finish thickness. When we enter these three details, we will get how much quantity of resin part A and part B is required, total resin, and cost per length. So now we need to open our map. So now we are seeing 37 meters. So total length is 37 meters plus we need to have 5 meters excess for tail end, and we need to account for the manhole depth also. Previously we calculated manhole depth as 14 meters because you will be installing the liner from top surface. That means your liner need to pass the manhole depth and then to the pipe. So 14 meters. Now it comes around 56 meters. Then usually you need to add 2 more meters for a factor of safety. So 58 meters. So we input the length as 58 meters. For 58 meters, now we need to include for diameter. Diameter is 300 mm. So we input as 300 mm. Then liner thickness we calculated as 8 mm thickness. So we put 8 mm. That's all. You will get part A resin quantity, part B resin quantity, total resin quantity. So this is the resin quantity we required. And from this resin quantity, you need to have 5% wastage also. You need to calculate additional 5%. So this ensures that we don't get stuck in any method process.
Yes, sir.
So that's all. We have done the third step also. Now we are going to look into job safety. So job safety is nothing but when you're executing the job, you need to have few documents on place. I will show you whatever it is. So this is the daily toolbox record. So before even we begin the work, we will put up a toolbox meeting and we will explain our workers what needs to be done and their names, what are the safety PPE they require, then what are the list of things we need to compare with, then what are the hazards involved in the job. So we are going to work at height, we are going to do manual handling, housekeeping, then are we going to use any electrical items? If the job involves slip, trip, falls, are we going to use dust? Or is there any fire involved in the job? All this needs to be explained to the workers. So after this toolbox is done, you are going to enter the manhole. So before you enter the manhole, before the worker enters the manhole, we need to open a confined space permit. So this ensures the man goes in, does not die inside the manhole, he comes back. So this is a safety mechanism, and it is by law in Singapore to have done all this safety permit system before we even start the work. This ensures that each and every job and each and every task involved in the job is being done with a safety mindset. So we don't just do the job, we do the job in a safe manner so that all the workers come to work and returns their home safely, not just come here and die inside the manhole. So these are the things how the safety system works here. You need to fill up all this, and here you can see the confined space assessor must evaluate the manhole for the safe gases. And I can show you this is the gas meter. And if you see the gas meter, it will have readings here. And once you take this gas meter and put it inside the manhole, and you will have a tube connection from here. And you need to put the tube inside the manhole and you need to watch out for the readings. So the safe oxygen level should be 20.9. The meter should show 20.9%. So if it is 20.9, you can enter the manhole. The workers can enter the manhole. And it also displays H2S gas, then CO in ppm terms. So if we determine if this meter shows H2S gas presence, then no man entry should be done, because H2S gas by smell you cannot determine whether the gas is present or not. And this is the reason why in India and in developing countries, many manhole scavengers or sewer cleaners, they enter the manhole and without knowing the danger, they die inside it. So in last year alone, I think in Tamil Nadu, 40 people died in sewer cleaning works. And in India, around, I think about 260 workers have died in sewer cleaning works. So they don't know the dangers involved here. They just open the manhole and it should not be done that way. We should assess the manhole. We should assess the underground infrastructure first before entering it. So after that, since we are parking on the roadside, we need to have a traffic control plan. How we are going to park our vehicle and how it is not going to disrupt the road users. So this is the traffic control plan. How we are going to in the work zone, we will be parking our lorries to do the survey, and you can see the traffic control devices placed here. And as safety measures, how it is by law, and TCP also is by law. In any of the Singapore road, you are going to occupy the road, you need to have this TCP plan submitted to LTA. LTA is Land Transport Authority and get their approval. So you need to submit this plan and work area, location, everything, and get their approval. So we'll see safety photos here from our site. So this is the emergency assembly point or rest area. In every site, you need to set up this, and it should have safety equipments like fire extinguisher, ACBA, tripod, everything. And this is one of the job we have done last month. You can see how the traffic safety cones are placed, and you can see the signboards, diversion. Then there's a traffic controller here, and there are two vehicles parked over here. So this is how we done, and you can see the accessing the manhole nearby the roadside, and you can see behind this picture there is a tanker over here. It is the downstream manhole where we clean the sewer. It is again a rest area. And this is how this is where you put all your permit papers, signboards here. You can see the organization chart, then safer procedures, risk assessment done, and the permit paper, toolbox paper, everything. And it should be displayed at the site at all times so that any public or any authority person or police or the safety person comes in, they verify these documents first. Without these documents, you cannot start work. So this is another site where we parked our tanker on the roadside, and you can see a go stop sign here, and there's another guy there controlling the traffic. And this is another area. So this is how we do this job. So job safety we have done. Now liner installation. I will quickly show you one case study here. If we go to so first I will show you the site photos, how it looks like. This is the site photo, and here is the upstream manhole. Here is the downstream manhole. Then this is the site photo. This pipe needs to be rehabbed because this pipe connecting to city side, and it is connecting to the water pumping station. So this pipe have 2 to 3 leaks, and the sewer water is leaking into the below lake. So this sewer water leak should be stopped. And this pipe is quite old, 30 to 40 years old. And instead of replacing the new pipe, PUB wants to rehab the pipe, because if we want to go and replace this entire pipe, you need to remove this entire section and you need to place new section, or you need to divert this. So it will take another 1 month to complete this job. So we don't want to waste 1 month just to settle these 3 leaks. So we took only 3 to 4 hours in the night time to complete this job. So this is the pre-con survey. I hope you can see my screen. You can see the project reference number, location, then pipe diameter, everything. And if you fast forward, you can see the precondition. This is the CCTV survey done inside the pipe, actual CCTV survey. You can see the pipe condition, how it looks like. It is a cast iron pipe, and you can see the scaling form throughout the pipe. So in this condition, it will be quite difficult for the pumping station to operate, and since it is having major leaks, they need to rectify these leaks also, because their pumping pumps will have malfunctions there. And you can see how hard the scale formation is. So I will just forward it. So this pipe, once we renewed, it will have the flow rate will be increased, so that from city side more sewer water can flow into the pumping station, and from pumping station it goes to the treatment plants. So that is the main objective of renewing this pipe. We can leave it as it is, then after 1 or 2 years it will completely collapse. And if this pipe collapse from the other side of the city, the sewer water, wastewater cannot pass to the pumping station and to the treatment plants, then it will have a major consequence in health and safety of the public. Because if this pipe is not working inside the city, the manholes gets filled up and overflow will happen, and which Singapore government doesn't like, and you will get fine for sewer water overflow, and the fine is quite heavy, starting from $1 lakh. So after we done the pre-con survey, we will need to clean the pipes first. So for cleaning, we will use the jetting tanker and chain cutters. So after cleaning, this video is taken after pipe cleaning. You have seen the pre-con how bad it looks like, and this is the same pipe after cleaning. So now here you can see the pipe scale has been reduced. We cannot remove the scales completely in a cast iron pipe, because if you remove that, then you will collapse the pipe entirely. If you see the pipe thickness also being reduced here in the side, you can see the pipe actual thickness is also reduced, and the pipe is in brittle condition now. So I will forward it. So this is how the pipe is looking after cleaning. So after cleaning, we went to the job site. So I will show you the installation photos. This is during installation. He is the installer supervisor, and he is controlling two valves over here. One valve is giving air to the liner, and one valve is giving steam to the liner to cure. The red hose is usually the steam. And this is the chain cutter we use to clean the pipe. It is for 600 mm diameter pipe. You can extend these wheels, and you can see the chains here, and it will be connected to the jetter. So water and this chain, it will be at the same time. Water will be flowing and cleaning it, and this chain will rotate and rub against this jetter. This is the resin wet out area. You can see the liner, and these hoses are vacuum hoses. We are removing the excess air inside the liner so that the wet out process and resin gets saturated well. So after wet out, we fill the truck with the ice. As I mentioned, when we are using polyester resin, we need to use ice to keep the liner for a longer period. This job, if you see the timestamp here, 4:24, the liner is being wet out, and the installation is during night time. So after wet out, the liner is put in. You can see the liner here, and these are the ice we are putting for the liner. So at the job site, this is at the job site. You can see the time. It is around 9:52 p.m. and my guys are having toolbox meeting, and he is the safety guy, safety supervisor, and he is explaining the hazards in the job and asking the persons to have proper PPE and how to carry out the job safely. And this is the toolbox record. And this is the manhole once we open it, and we waited for the water to drain it. In the pumping station, they switch off the pump for 8 hours for us to carry out our works. So as you can see, the pumping station is losing only 8 hours to renew this pipeline, comparing it with 1 month for replacing it. So you can see from the lorry, we are passing this liner. It is a crane lorry attached with the crane. We use this crane lorry to pass the liner, and you can see on the other side, the guys are waiting there for the liner. So the liner is passed to it, and the installation process begins. This is the camera we used for the process, and this is the team. You can see the workers, number of workers: 1, 2, 3, 4, 5, 6, 7. 6 workers, 1 supervisor, 1 engineer. That's all it requires to renew this entire pipe. And it took us 8 hours to renew this pipe. So after installation, there is no more leak, and there is an increased flow capacity for the pumping station from the city area. So there is no more choke or no more water stagnant in the manholes in the city area. So this is one of the reasons, and I'll show you a CCTV report. So after cleaning, lining is installed. This is the liner installed in the pipe. Now you can see how the liner looks like. So you have seen the pre-con photos, how bad the pipe was. Then after cleaning, you saw the photos, and this is after lining, and this is how the pipe looks after lining. So if you see, this entire pipe has been rehabilitated and looks very new, like a brand new pipe, and it is going to last for another 50 years here. And the survey has been completed. This is the post-con survey. So after post-con survey, we will make the survey into the report. You can see the report here. This is how CCTV survey report looks like. So there are five classes of failures or five conditions. And if you see here, okay, this is the general details, and this is the pipe profile. And at each meterage of the pipe, what is the condition? It will be noted here with the picture. If you come below, so start, then it is at 0 meters, then at 10.58 meters, then at 30.29 meters. So this is how the CCTV report looks like. So we have seen how the job is executed in actual area. So I have shown you my previous jobs, our company's previous job here, and let me show you the other jobs we have done. So you can see the big diameter pipes here. You can see the liner, how big it looks like. It is 2500 mm diameter, and you can see the vacuum pumps running over here, number of vacuum pumps, and cranes has been used to install the liner. On the right corner, you can see after the liner installation how it looks like. And this is a project in Indonesia, which we have done recently. It is for a tailing plant. Tailing plant is a mineral processing plant. So this pipelines you see, rubber pipelines you see here, HTP pipelines. Usually in tailing pipelines, they transfer the minerals from their source to the mineral plant, or from the mineral plant to the waste area. So when they are transferring these minerals, their pipeline should be in good condition. So what they do is actually in the 6 o'clock position, the pipe 6 o'clock position means in the inward level of the pipe here. Here, every 2 years once it gets weird. I mean the surface get weird. Then after that, the company changes this all pipelines, entire pipelines every 2 years. Then they came to us to have a solution to extend their pipelines. So imagine if you are going to replace all this pipeline 2 years once just because of one defect at one location. It is very huge, and they wanted to save that cost. And the cost you can see it is compared to $1 million. $1 million means it's quite heavy and huge. So what we have proposed is we proposed a UV lining system, and before the pipe has been deployed to the tailing pipes, we install the liner system here, and the pipe has been deployed. Then now the pipe is lasting for up to 6 years without any problem. And after 6 years, they do a CC inspection, and if there is any damage, we will just reline it over again, and we don't need to replace the hose pipe. So these are the advantages of lining trenchless technologies here. And all the while we are doing this detailing power plant, they don't need to shut down the pipeline for a longer period. As I mentioned, usually we take 8 hours to 14 hours for big pipelines. So that is the advantage. And you can see pipe lining is in process here, and it is an oil rig in mid of the ocean. And this is Permaliner guys from US team carrying out this liner. And it is another example of industry pipeline, chemical industry pipeline, which is being lined with pull-in-place liner system. You can see the pull-in-place liner is installed here, and you can see the thickness is quite heavy here, and it is because of the pressure pipe. So these are our partners. I hope you have you have gained some knowledge about trenchless technology, and it is quite new in India and developing countries. I will stop sharing my screen. So within 1 hour, it was difficult to cover all this, but I hope I have covered basic details about trenchless technology and how the lining is installed, and in Singapore, how the actual job is being executed. and design parameters, properties of the liner I have explained, and more importantly, how we take care of our workers using job safety analysis and risk assessment. And you have seen the photos of how the actual job is carried out in Singapore. So this is the in Singapore. There's a saying: uh, you don't want to complete the job without any safety. So you rather don't do the job or you lose money. So if you carry out a job without safety, and if there is an incident happening in your job site, then it will incur 3 to 4 times the cost of following the rules, not following the rules. So here we don't risk in compromising the safety of the workers. And in generally speaking of this industry, I have seen rapid development in India also. There is a Trenchless Technology Association set up in India last year, and there are 10 members in the association. And our company is also expressed the interest in joining it. So I will show you a quick site visit. Last year we have done a site visit in Mumbai. You see, this is a pipeline in Mumbai from city to the pumping station. So all this area behind these houses, the pipeline is crossing. The pipeline diameter is 1,200 mm. So Mumbai Corporation is looking to rehab this pipeline. This is the pipe condition. So Mumbai Corporation is looking to rehab this pipeline system without disturbing any of this area. So if you want to replace the pipeline, I mean you want to excavate and replace it, you need to break all this. So you need to dig a trench inside this establishments. So it is quite tedious, and these areas all you need to cut the pipelines, rehab with new one. So instead of this, Mumbai is considering for a trenchless CIPP lining, and they have executed 3 to 4 projects in India so far. And in India, still this technology is being studied. And unlike other developed countries, we don't have exact maps. I mean, sewer information plan. So they are developing the maps also. It is called asset management plans. So I hope in future there is going to be a huge growth in this industry, and it is a very closed industry, not like a general contractors, conventional methods. In general contractors or conventional construction techniques, you will have vast companies, and there are many people involved in that. But this industry, trenchless technology industry, is a very closed loop. And in Singapore, only 6 companies are doing this CIPP rehabilitation and CCV inspection works, and we are one of them. So as you can see, the number of companies and the number of technologies, everything is limited and controlled, and there's a huge scope in this. So if you happen to be in this industry, it is a quite interesting one, unlike a conventional one. And the design technical parts is quite straightforward. So there are many technical considerations which we cannot discuss here. So maybe in future I can show you. After this presentation, I will send all the documents, presentation, slides, everything. So you can take a look at it, and I will send you the design calculation sheet also to work on. And I will send sample SIP maps to compare how it is there. So Permaliner is having a educational university also, which we where we train new installers through live training, and this training is conducted yearly once in US and Singapore also. These are our company partners, various technologies. So I hope the webinar is coming to an end, and these are my contact details. You can, if you have any questions, you can post to my email address over here, and it is my hand phone number here. You can contact me in WhatsApp. I'm not in Facebook, active in Facebook or any other medium. I'm active in email. So email or WhatsApp, you can ask me doubts. So I hope that's it. Okay, I'm seeing some questions here. Okay, First question: when using the system, the liner must be in dry condition or not? So when we are using the system, the liner will be in dry condition only, and the resin will be mixed and poured in. So the liner is in dry condition. And more importantly, the pipe should be also in dry condition. Once you do the flushing work, the water inside the pipe must be removed. This is because, as I mentioned, the liner curing, right? We are sending in hot air or hot water inside it. So if we are sending hot air and there is water inside it, the curing process will not be effective. So the pipe should be free from water infiltrations, and the liner is in dry condition period. Then after that, once resin is poured, it will be wet condition. And there is another question: what is the advantages by using this technology? Okay, as I mentioned this, you don't want to disturb the above surface utilities or above surface construction premises, anything. For example, I showed you images on roadside how we are doing it. If you were to replace these pipes by conventional means, you need to excavate the entire area. You need to block the roads. You need to disrupt the traffic flow, everything, and you need to open the trench, and after that you need to excavate the pipe and put new pipes. All this process takes time. It minimum 1 month for replacing 50 or 80 meters pipeline, and for 1 month this pipe cannot be used. So we are saving time and cost here, and more importantly, we are not going to disturb or disrupt the traffics. So we will occupy the lane for night time, and we will do our work within 8 hours. By morning, when the traffic resumes on the road, we will be out of the site. So this is one advantage of this technology. So another question: the machine that used for this technology is so huge. Is there any portable system for application in narrow area? Actually, the machines, the photo looks big, but there is a portable system also. The immersion gun is a small system which we take inside the house also. I can show you one photo.
எவ்வளோ நேரம் வரைக்கும் பொறுத்தோம் சரி போடுங்க ஏன்னா எனக்கு 1 to 2 செஷன் இருக்குது 2 o'clock வரைக்கும் போட்டு விட்ருங்க 2 o'clock.
So you can see my screen now. If you see here, the system is completely mobile. You can see inside the house we are installing the liner, and this is how it looks like. And we have, so okay, this is the manhole after lining installation. You note the you see how the manhole is clean here, so you don't see any dust, you don't see any choke in the manhole. So I hope you can imagine if we go in like a metropolitan city in India and we open up the manhole and we see, you can imagine how it looks like. Usually there are chokes or water inflow because the pipelines are not maintained properly. But in developed countries they maintain, and in India also they maintain in urban cities. Now underground pipelines, they are taking care more nice compared to earlier times. So usually this is how all the manholes in Singapore looks like. It will be quite clean, and here you can see a pull in place liner system. So coming back to the topic, I can show you a portable system here. So this is the portable mini gun which we use for a narrow area or we don't have any space. So only this gun we take inside the house, we set it up and we install the liner. So next question, the disadvantages of this method. Okay, like just a minute. Okay, the disadvantage, like any other method, this method has some consequence also. So when you're dealing with resins, epoxy, if the mixing is not done well or the installation is not done well, the liner install liner will have problems. If the liner has the problem, then it will take 2x the cost to rectify it, depending on the location. So the disadvantage I can only see of if the quality control is not done properly, you will have liner failures ultimately. These liner failures are ultimately very hard to rectify it. You need to send in robotic cutters to cut the liner, and you need to reinstall the liners. So other than this, there was one research paper going on whether the install liner is releasing styrene chemical compound in COS. And after this research paper is out, many manufacturers moved from styrene-based resins to epoxy and UV lining system. So now that issue has been resolved. So other than that, this method is having very least disadvantages. In fact, instead of disadvantages, it is having more plus points compared to the conventional system of replacing the pipes. So, if the lining process going wrong, next question, how we know about that? Is there any sensor? Yes, actually, we have a few monitoring system. As I showed, we will have a computer system which monitors the liner. So once the liner is installed and the pressure is given, the pressure should be maintained at zero point 0.8 bar. So if, for example, the inflator liner is punctured or have any defects, the pressure drops. So we will know the pressure is not holding it up, and we will immediately rectify it. And during the curing, this curing process should be in a slow phase. So it should not be like rapid from 0 degree to 70 degree within 15-20 minutes. It should be slow, like 20 minutes, 30 minutes, and until 2 hours, this temperature increase should be a step-by-step process. After it reaches 70 degrees, then the cooling down process should be also slow. Like we need to give some time until 1 hour for curing. So if any of this process is going wrong, it will be informed by our sensors, and we have a separate system to monitor the lining. But you cannot see inside the liner how it is installed, or whether it is having a lump or it is having any tear up surface inside the liner. You cannot see that because it is connected to the steamer, and you cannot send in the camera at that time. So inside the liner, we will not know, but other than that, we will be monitoring all the critical parameters. So if you address the critical parameters, there will not be any trouble inside the liner. So after the lining process is complete, we send in our CCTV camera, we do a check whether the liner is okay or not. So there is another question. So during the repair of old pipe, how the liner behaves at the holes where it pulled out. So we don't need to bother about the holes. So I will show you a sample pipe. So here it is I will quickly show you the exact one. So this is the pre-con done. If you see here, there is infiltration flowing in. You can see the infiltration. You can see the infiltration flowing in, and you can see the jetter truck doing the flushing work. And here you can see the joint displacement, which are small holes where it is a pipe displacement in there. And you can see how the jetting work is going on. And we are following it with the CCTV camera. So after that, even is bigger. For example, if you determine the hole is bigger, or if we found there is infiltration coming inside the pipe, if water comes inside the pipe during our curing process, it reacts with our resin. Then the liner will be in bad shape. So to avoid that, if there is a large hole or huge hole, more than 20 shape, and if there is infiltration, we will do a sectional repair. Sectional repair is to address the hole or infiltration. You see this? There is a steel casing. It looks like a steel casing, and it is installed inside the pipe. So I will not go into detail how this is installed. It is a big topic again. So wherever we find a huge pipe displacement and holes or infiltration, we install this stainless repair patch. So we patch it up with this stainless repair sheet. Then after that, once this is installed, infiltration is stopped. then we install liner. So this is how we deal with the holes or infiltration. Again, there is a question: can the liner install when it is wet? No, we cannot install the liner when the pipe is in wet condition because it will affect the curing process. Okay, so I hope these are the questions and I had addressed the questions. If you have any more questions, you can post it to me. I will share my email ID and contact details. So I hope you can see my contact details here. This is my email ID and my handphone number. If you have any doubts or how this industry works, what are the companies, how the employment in this industry looks like, what are the positions, everything. If you have any doubt on these things, you can always reach to me. And if you want to learn more about it, I can send you the documents and usually you can Google search it yourself. Just use CIPP lining system or Trenchless technology. You will get lots of informations. And if there is anything I can help you out, you can reach to me. Feel free to reach to me. Okay. I hope the webinar is coming to an end.
Okay, thank you, Adi sir, for this wonderful session. On behalf of Department of Civil Engineering, Johnson's Institute of Technology, I thank and congratulate the participants from the various parts of the country. Thank you for your support. Thank you all.
Yeah, thanks. Thanks.
Thank you.
Hello. Okay, thank you.